We have two discrete random variables x and y which we are told are independent random variables. And if two random variables are independent, that means that the conditional probability, so the probability that x is equal to a particular value given that y takes on a particular value, is equal to the unconditional or marginal probability. Now, in order to calculate the joint probability that x takes on a particular value, let's say little x, and y takes on a particular value, little y, we can calculate this by finding the product of either the probability that x is equal to x multiplied by the conditional probability that y is equal to y given x is equal to x, or the probability that y takes on a particular value, little y, times by the probability that x is equal to x conditional that y is equal to little y. Now, if these are independent random variables, then the conditional probability is just equal to the marginal probability. So this conditional probability that y is equal to y given x takes on a particular value x is just the same as the probability that y is equal to y. Similarly, the conditional probability that x is equal to x given y is equal to y is just the same as the marginal probability, the probability that x is equal to x. So we can rewrite this as being equal to the probability that x is equal to x times by the probability that y is equal to y, or this is equal to the probability that y is equal to y times by the probability that x is equal to x. So if two random variables are independent, then the joint probability is just equal to the product of the two marginal probabilities. Now, we're going to use this joint probability here to write down the expectation of xy. And the expectation of xy we can get, because these are discrete random variables, this is equal to the sum over all possible values that x takes of the sum of over all possible values that y take of the probability that x is equal to x and y is equal to y, so our joint probability times by all of the possible outcomes of x and y. So we're going to sum over all possible values of x and all possible values of y of this product. But we know from above that this joint probability is just equal to the product of the two marginal probabilities. So we can rewrite this as being equal to the sum over all values of x of the sum over all values of y of the probability that x is equal to x times by the probability that y is equal to y times by x times by y. Now, for each value of y, this probability that x is equal to a particular value, little x, is fixed, as is the value of little x. So those can be taken outside of that second summation. So we can rewrite this as being equal to the sum over all values of x of the probability that x is equal to x times by x times by the sum over all values of y of the probability that y is equal to a particular value y times by little y. But we know that this term here is just equal to the expectation of y, so we can rewrite this again as the sum over all values of x of the probability that x is equal to x times by x times by our expectation of y, which is a constant, which can be taken outside of the summation, giving us this is equal to the expectation of y times by the sum over all possible values of x of the probability that x is equal to x times by x. But again, this summation here is just the sum of the outcomes multiplied by their probabilities, which is just equal to the expectation of x. So our expectation of xy, if x and y are independent random variables, is just equal to the product of the expectations. Now we can use this to now calculate the covariance. So the covariance between x and y is just equal to the expectation of xy minus the expectation of x times by the expectation of y. But we know from above that if x and y are independent, that this expectation of xy is just equal to the expectation of x times by the expectation of y. So our covariance is just the expectation of x times by the expectation of y minus the expectation of x multiplied by the expectation of y, which is equal to 0. So if two random variables are independent, it must follow that the covariance is equal to 0, and also the correlation between x and y, which remember is equal to the covariance between x and y over the square root of the product of the variances, is also going to be equal to 0.